Hello everyone, I'm here today to talk about a super cool feature of the Linux kernel. This feature has been around for a long time, but it is not really used by many tools or not many people know about it. It's called delay accounting. First, just a bit about myself. My name is Carvalho. I'm an engineer at Global.com, which is part of the major media company from Brazil. I work at Suru, maintaining our open source platform as a service. And you can find me on Twitter or on my personal sites. So when our code is running in production on a server, it runs alongside many more processes. So we have daemons, agents, we have kernel threads, and we may also have other applications, especially in a containerized environment. So all these processes are fighting for machine resources, and the Linux kernel tries to do a good job scheduling everything, making sure that everyone has a fair share of all the resources. But sometimes things go wrong, and we have too much workload, or we have higher processes that are stealing other applications' processing time, and so on. So tasks may encounter some delay during execution, waiting for kernel resources. For instance, we may have a process that wants to run in a CPU, but can't simply because all CPUs are taken. So the kernel puts this process in a run queue and makes sure that whenever a CPU is free or a process is done processing, doing its stuff, the process is going to be brought into the CPU and it's going to run. But this may take a while. So it would be interesting to know how long these delays are taking. So just to maybe know if you are if your workload in this server is more than it should be taking. So Linux exposes delay encountered by tasks, and these delays may be waiting for a CPU while the process is in a runnable. May also be waiting for synchronous block I/O to finish, swapping memory pages in and out, and also during memory reclaim. So all this information is useful and can be used to make sure that we are not to analyze system saturation, and also for configuring task priorities. So if I know that an important process may be experiencing higher delays, maybe I should configure its task priority to a higher level so it doesn't experience those delays. And as I said, this feature is available for a long time in the Linux kernel, since 2.6, and was recently added to HTOP, so you can use HTOP to monitor these delays. All this information is exposed by the kernel via the netlink interface, more specifically the task-stat interface, and the netlink interface is simply an interface that user space programs can use to communicate with the kernel by exchanging messages. The Linux source code comes with an example of how one could approach getting those delay information. I've rewritten that using higher level libraries to make it easier for people to understand how it works under the hood. But it's still C, so it's complicated. But unfortunately, the tool that wants to extract this information needs to run as root or with some special capabilities. So since it is a Go conference, MathLayer has built a really nice library called TaskStats. It's a library that exposes delay accounting information and also some other information. And I've started a simple CLI tool using his library to expose delay accounting information for a given process or thread group. It's a working process. I just started the repo, so if someone wants to contribute, just reach out to me. Now let's do a simple demo of the tool. So here I'm going to use the delay stat tool to get the delay information from the process with speed 1. So here we can see that we got multiple columns. Each column refers to a resource. So we have the first column showing the CPU delay. So this is the amount of time that the process was ready to run but couldn't because all the CPU were in use. And we can see that it averaged in the order of microseconds. So since it starts, the average delay experienced by PID1 was 13 microseconds. Now, let's generate some workload here to see how that might work on a more interesting case. So here we are going to use the express utility to generate some workload. So we are going to start 4 processes that are going to use CPU. Let's use the verbose flag. So here, this is a 4-core machine, so I have 4 processes running on my CPU. And I'm going to start the express process also down here, but here I'm using the nice command to set it to a low priority. So these processes are going to have a low priority in comparison to all others. And now we are going to use the delay stats tool to see how they are doing in terms of delay. So here we are going to grab the first one. Here we are seeing that it's experiencing delays in the order of microseconds, around 200 microseconds in average. And down here, we are going to see the delay encountered by the other one, the one with the lower priority. And here you can see that the delay encountered by this one is in the order of 15 milliseconds, which is much higher than the other one. So we can use this information to fine-tune the priorities on the process on our system. So let's go. So this is a couple of references that I recommend on the subject. So if you're interested in any of that, I recommend checking out. Thanks.